Let's go through LeetCode 399 evaluation divisions. So it gives us a list of this string equation and which represent the division of the equation, and also the values, which is double array, which is division's values, and also give us a query list of this string queries, and let's return the query result. If for the query, there's no result return -1.0 to count double. It is and otherwise just the division result. It let us to return the double array. So we'll see if it give us those kind of equation, for example A, B, B, C, and A divided by B equals 2.0, B divided by C equals 3.0. So we'll see those kind of division get those kind of strings like A, B, C connected, have some connections. So intuitively, what I was thinking about is that we do this question in a union find way. Union find, there are two ways. One is we know the union find template class. There is a class union find. The one way is use an int further. Right? For this question, of course, we can from the list string questions to map those kind of strings to integer, and we can also use the map way string further equals new hash map, and so this kind of unified class template. Let's write this, right. So we are going to have public void union string A, string B. So I say string FA underscore A equals find A, string FA underscore B equals find B. So I say if FA underscore A done equals FA underscore B, then we'll just have further put FA underscore A to be FA underscore B. So let's A's root FA or FA is a root pointing to the FA the B's root, right? Yeah. So that is we put this one the parents to be FAB. So also the union public string, also the find, right? String x. So what we have is that if x equals f a further get x, then just return x. Otherwise, we are going to have string fa underscore x equals find further get x, and we're going to have further put x of a dot x. Then we have return a dot x, right? So there is the recursive call. Every time we have this one, we have a path compression. So this will be the union find class template for map style. For this one, when we union or do the find, right, we need to pass in the ratios. So, for example, if we have a union B, for this union find class, we should have some kind of ratios to be passing. So we can change this kind of union find class a little bit. So how can we change? We can add a map string bubble the ratio map. So what does this one mean is that for every string, for every string, it divided by its root. So, and for example, ratio get A will be A divided by root A. Um, so, for example, if we have a double value, right? So this value is A divided by B. Then we should also have what we want is that uh, we need a ratio. Um, so this ratio should also update, right? Ratio should put FA underscore A, right? So what will this be? After union should here what we need is FA underscore A divided by root FA underscore A, right? So what is the root FA underscore A? So now the root, because the root change, that is actually FA underscore B, right? So but we don't have um values for this, right? So we should use our current values. So how can we calculate FA underscore A divided by FA underscore B? So we'll say let's have some calculations. FA underscore A divided by FA underscore B should be equals to A be divided by ratio A, right? And divided by B divided by ratio B, right? So this one will equals A divided by B multiplied by ratio B divided by ratio A, right? So that will be V multiplied by ratio B divided by ratio A, right? So this one, when we put what we need to put is V multiplied by ratio get B divided by ratio get A, right? So we should also update the ratio map as well. And also when we do the path compression, right, in the find part, because we are connect x to father x, not father x, that is a find, right? FA find father x. So there is a kind of root compression here, right? So here we should also update when we do the compression, we should also update the ratio um, ratio map. So what we do is that we are going to have a string called original fa underscore x equals father get x father get x father get x um yeah, or original, right? So the thing is that so that we keep this value. And then this one we can replace as original FA underscore X, right? And this. And then we put this between this. But we need to update our ratio map, right? So what when we do this is that our ratio, right, should put the what? Put um X a new ratio, right? So here, what we want to put is ratio divided by find X, right? So this one equals X should be X divided by find X, right? X divided by original FA multiplied by original FA underscore X divided by find X, right? So this will be ratio. So um, ratio get X, right? So this one multiplied by ratio get original underscore FA X, right? So what we need to put is a new X divided by find. So will be ratio ratio get X multiplied by ratio get original underscore FA X, right? So the hard part is that when we this kind of union you find function, it has a weight map. So when we union, we should update the weight. And also when we do the pass the pass compression, we also need to update the ratio map. Um, So if we have this kind of unified function, the other part should be easy. Let's write the whole functions, right? So we need a union find UF equals new union find. Um, then what we do is set for int I equals to 0, I smaller than equations and dot size I plus plus. So we're going to have a string A equals equations get I get 0, and we're going to have string B equals equations get I get 1. Then what we do is that if UF dot so this is if UF dot further contains key, right? But contains key doesn't contains key A. Then we need to add this one to its map. So what we do is that we need to have UF dot further put the A, and also we need to have the ratio, right? UF dot ratio put A 1.0. The same thing to B, right? If you F dot further that contains key B, right? That contains B, then we're going to have UF dot further um, put B, and also UF dot ratio put B 1.0, right? So this is then what we do is that we should union UF dot union A, B, and also these kind of values are right. And for our query, after this one, then we need a query that is int q equals queries dot size. So what we do is that for then we have double result equals new double q, right? For int I equals to 0, I smaller than q, I plus plus, then we can have string AB, right? String A equals queries get I dot get 0, and string B equals queries get I get B, right? Get one. So here it is possible that the query has a string which we didn't add to our union find map. So we should check if it contains key or not, right? So we should write if uf dot father contains key a or uf dot father contains key b or or if another case is that this A and B, they are not connected, right? So there is no equation to convert. So we should add the third condition is that UF dot find A done equals UF dot find B. In these three cases, we just result I equals minus 1.0, right? Otherwise, we just result I should be equals UF dot ratio get A if their root is the same, right? So that is A divided by root and divided by ratio get B, right? B divided by ratio, right? So that is so here is A divided by root A, right? Divided by B divided by root B. And as root A and B are the same, right? As so that will be A divided by B because root A equals root B, right? So this will be the result and return result. Um, if UF dot further contains key, right? Not contains keys. So this will be the union find solution. And doing union find, we'll see those kind of for union find, we'll see those kind of union and find those operation is log star and is some kind of very small, less than 5 or 6 number. So we can consider that union and find some kind of constant or one operation. And here, because we from the equations, right? So we have the union operations that will be O number of equations that is OE, right? And query that is OQ, right? For every query, we um, just use uh, get to divide, right? And also check if they have the same parents. Those operations are all O1. So that the time complexity will OE plus Q. The second part is Q, right? So space complexity is also this map. Map will have um values, right? And also the queries that is double size Q, also E plus Q. We can also write a Python code for this. We're going to define unified. It will when we IT self, then we're going to have a self data father equals to this, right? And self data ratio equals yes, two maps. And we need to have def union. So I should have self A, B, and this kind of way, right? This ratio A divided by B. We have so we are going to have A underscore A equals self dot find A, and FA underscore B equals to self dot find B, right? So I say if FA underscore A in Python we can just use equal FA underscore B. Then we're going to have self dot parent father FA underscore A equals FA underscore B, right? And also we should update the ratio function itself dot ratio FA underscore A equals self dot ratio ratio B multiplied by value divided by self dot ratio A, right? So this will be the union method. And also we need to define find self X. So we set we're going to have if X find equal to self dot father X. So if it equals, right, just return X, return X, right? So if it doesn't equal, then we need two parameters. One is the original fa dot x equals self dot father x, and then self dot father x equals self dot find original fa underscore x, right? So there is a recursive call. And also we need to update the self dot ratio X should we can also write like this: multiply equal self dot ratio O fa dot X and then return self dot fa for the extra. So something like this. Um, so then what we need is also in the main function, we need to define UF equals union prime, right? Then what we do is for A, B, and also value. We can use zip function, equations, values. Then we are going to have if A not in UF dot father, right? Father. Then we're going to UF dot father A equals A, and UF dot ratio A equals 1.0, right? And also, if B not in UF dot father, then we're going to UF dot father B equals B, and UF dot ratio B equals 1.0, right? Uh, so otherwise, we need to UF dot union A, B, and this kind of value, right? So we just use V, V, right? And then we are going to have result equals list for A, B in Paris. And if not A, not in UF of the father, or B not in UF of the father, or UF dot find A doesn't equal to UF dot find B, right? So that means A, B, they are not in the same connected components. Then we'll just the result should append -1. Right? Else, we're going to have results should append UF ratio A divided by UF dot ratio B, right? So in the end, what we is need to return results.